All right, so today we're going to look at the SymboLinkLink testing tools. I hope I pronounced that right. By Google Project Zero. This is a suite of binaries that are pretty helpful with privilege escalation. Today we're going to look at setOpLock because this is pretty helpful when exploiting like race conditions. I'll tell you what it does later. This is created by James Forshaw, the godfather of Windows exploitation when it comes to privilege escalation. He's got a bunch of CVEs and he's been doing this since, 2015. There's a reason he's in Google Project Zero. Pretty awesome guy, pretty smart guy. All right. So you can just get the binaries on their GitHub. I'm going to link it below in the description so it's easier. You just go on code and then you just download the code. And then you should open it up in Visual Studio. You can just double click the solution file. Also, if you don't know how to open up repos in Visual Studio, then you shouldn't be allowed to use the binaries because learn how to code first, right? Right, because why the fuck are you still a script kiddie in 2025, bro? That's you should not be a script kiddie in 2025. All right. Now, as you can see, there's a bunch of projects. They're all imported in the same thing. Now you can hit Control Shift B to compile them. And they're all already compiled. So let me just see where I put these. I think I put these in the exact same directory where I usually put everything. Let's go to, I'm about to leak a bunch of shit, bro. You can see all my secrets, man. Source, right, repos now. Bro, I did not. There you go. Now we can go to debug, and here are all the binaries. We have setOpLock right here, and we're just gonna copy the path of this binary. F my $100 computer would. Thank you. All right. Now, how am I going to showcase this? Well, we have ExpressVPN right here. And this is kind of sort of a vulnerability I found. It's not a vulnerability really. It's just a cool trick to where you could exchange DLLs, like signed DLLs that it loads and it checks the signature for your own DLLs. You can bypass the signature check. But I'm not going to show you that right here because that's only for the Discord community. Link below. But I am going to show you part of it to showcase the setOpLock binary. Okay, so we have ExpressVPN updater, and this accesses. Just go into that directory, maybe. Like, is there a way I can? Okay, something like this. This is pretty ugly. Okay, let's just go to local app data. Local app data. App data local, and then I think it was test, and then test Costura, and then here we go, this right here, and it tries to access these files. It tries to access this file first, which you can exchange by setting an oplock right here. Like I said, if you want to see how that works, join the Discord community. I haven't put a video about that in the Discord community yet, but I think I'm going to give a live talk about it. So, join if you want to. But it first accesses this file and then it accesses this file. So what we can do is we have the path to the setOpLock binary. And now is the time where I should explain to you how oplocks even work. So imagine you're in a library and you tell the library person, like the cute, thick woman that works there, got like big boobies. You tell her that you want a book and you want to take it in the back room to read it and modify it and whatever, right? And she tells you, all right, sure, here you go. And you tell her, okay, as soon as somebody comes, I can just give the book back because you'll let me go in the back with the book alone. And she says, all right, perfect. And then as soon as somebody comes, you give the book back. That's how an uplock works. An uplock is basically you have you set a lock on that file. Like basically you take that file and put it into memory so that you don't have to ask the disk over and over again. And whenever you have that lock on that file and you basically tell the OS, I promise you I'm the only person like modifying this file right now. So please set a lock on that file so that whenever somebody comes, I can just come back and I can give you the file, right? Because it's being modified right now by me. So you're basically saying, I want to modify this file. If somebody else modifies, stop them, and then wait until I'm finished modifying this file. I'll give it back and he can use it. That's how it works. So what we can do with that is if it accesses this file, we know that by looking at progmon, and we see it accesses this file, we can just set an oplog on this file, and then when it accesses this file, it waits, because it has to wait for us to be done modifying the file, even if we don't modify it. We told the OS we were modifying it. And then only then, when we release the lock, it continues. So that way, we can find out via progmon what files it's accessing. And then at the exact point where you need it to stop the program, you can just make it stop by setting an oplog on that exact file. So what we can do is, if you look at the arguments, we have the different permissions. Because when you do a create file, a call on a file, you have to give the call different permissions. You're going to tell the librarian what you're going to do with the book, right? Are you only going to read it? Are you only going to write in it? Are you going to delete it? Or are you going to tell the librarian, okay, only I want to access it. Please log everybody. And usually you can just take all permissions and it works like that. But if it doesn't work, you just play around with just R, just W, just D, or RD, or RDX, because you have to have the same permissions, or at least the same permissions, that the program that you want to try to get to hang, you have to have at least the same permissions. Because imagine you're in that library and you are modifying the book, right? You're writing into it right now and it's open like this. If the person that you want to hold, that you want to hang, comes into the back room as well and just reads the cover of that book, that's possible while you're modifying the book, because it only needed the title. Like if another program only like needs the metadata, for example, it can just do that, even though if you have only file write, then you would need an exclusive lock. So just try and play around with all of these until one hits. And yeah, that should usually work. So this file right here, like this binary, stops at exactly this right here. And beforehand, it replaces this DLL. You can see it's only 62 kilobytes. That's because it's mine, like my fake one. This is the real one. I already like exchanged those. If I'm actually gonna change this back. So right now, if I would have kept this right here, the program would have replaced this with its own DLL, like with its own gRPC, because the signature didn't match. But now, after checking the signature of this, it checks the signature of this, but if we get it to hang right here, the signature of this is already checked, and we can replace this before it gets loaded. Like, the program checking this file right here is right in between it loading the DLL and checking the signature. So it checks the signature, then we hang it, and it's hanged with the signature already checked. So now we can replace the DLL, and then we can continue it, and then it loads our DLL, even though thinking, okay, the signature is valid. Yeah, so if we set an oblog to, or rather, let me try and, so you can see that it actually gets replaced. grpc.core.dll. Wait, let me, because this is the legit one. grpc.core.dll. You're going to see that this is going to get replaced. We're not going to set the oblog yet. But as you can see, boom. That's right here. And the other one also gets placed into here. So bam, it got replaced, right? It's, all right, I do not want to open that. Okay. So it gets replaced if it's not the one it's expecting. This is not the one fucking hell, man. This is not the one it's expecting, so it would get replaced. Now, if you set an oblog on this file, take that here, set an oblog on this file, and we're going to do rwdx. It's going to tell us, oh, oblog triggered, press enter to, you know, release it. Boom, oblog triggered because it tried to access the file. And now it's basically hung here, and it's already tried to, it's already verified that signature. We can, sorry, the camera died. We can delete the file. Boom, grpc.core.dll. And what this DLL does is it places the output of whoami into C users public, whoami text. It does this, and basically to show you proof that it actually works. Like if we now release it, it already checked the signature, then we replaced it, so now it tries to load it, right? Bam, it gets loaded. There's a command prompt that popped up, and as you can see, whoami.txt is right here. And since I myself started the program, it's still the same user, but you know, we essentially bypassed the signature check. Yeah, so that's how you use oblogs. You can basically hang a process right where you want it to, you know, essentially exploit race conditions reliably. Pretty cool binary. Yeah. There are other things in the symbolic link. Oh, fucking hell, man. In that repo, like create, where is it? Create registry symlink. Yeah, you can actually do that, and you can proxy registry entries. Can do some pretty cool stuff with that as well. But yeah, that's it for today.